here we have, so, there we go. There. I'm a little bit hesitant today, even more than I usually am, because last night my computer updated to Windows 11, and that is always a scary proposition, isn't it? Because all sorts of things can and probably will go wrong today, but I don't know what they're going to be yet, because I haven't really had the chance to do anything except, for instance, I had to get it to figure out where my mic was, which wasn't fun. Anyway, back to this. Here is an example of question 11. It's a pretty standard type of question that we were doing. You've got a piecewise function. This one's a little bit simpler than sum. It's only got 2 pieces to it. And I did it in Desmos and it looks like that. And it's one of those questions where you get lots of different choices and your job is to check which ones are true. So if I look at this piecewise function, there's definitely something happening at -1, which is why they're saying that. So here goes. The first one says, the limit as x tends to -1, f of x does not exist. Well, let's look at that. Would you agree that the overall limit here does not exist? So, put a check mark on it. But there could, and there probably will be, lots of check marks. No particular reason. Let's go at this thing. Is it true to say that the value of the function at -1 is undefined? Now let's look at the function at -1. Is it true to say that it's undefined? Now that's not the same as the limit. Is the value of the function undefined? No. Isn't the value of the function 3 because there's a solid dot there? Now, if it was undefined, your shape would look more like this, right? Wouldn't there be 2 holes, right? One's a dot and the other's a hole, right? So leave it alone. You only check the ones that are true. And none of the above. I don't think I've done one homework question where that was actually valid, so I'm not even going to go there. Now, this one's a little bit more, got to be careful because there's actually 2 things going on and both have to be true before you can say yes. The value of the function at -1 and the overall limit are finite, right? It means they're a number, but they're not equal to each other. Well, that guy does exist, it's 3. But isn't the overall limit doesn't exist? So that isn't true. It's not true because this is not finite. This is I do not exist. So if they had said, I don't know how they'd phrase that one, but it's just not true. And this one says the left limit and the right limit, should have to get that the other way around, the right limit and the left limit are finite but not equal. And that is true. So do you see in this example, there's only 2 that are true, right? True statements, and the other 3 are false. So when you're doing these questions, you really need to know what the thing looks like. That's what Desmos is for. Once you've got a picture in front of you, it's important to know who gets the -1. So here, x is less than or equal to -1 means that this curve here, this straight line here, that gets the point with a dot at the end. And since this one is greater than, that means this one doesn't. I could have put in a couple of other ones. So since this one is here, is this function left continuous at -1? Is this function left continuous at -1?
Yes.
And we know that, correct. We know that for what visual reason? What was the clue?
Because there's a line that goes left from the solid dot.
We're a solid dot, right? And this is not right continuous. Why do we know it's not right continuous? Well, there's no dot there, right? Are we cool with these questions, or do you want me to do another one that you've came across, say, in your homework situation? I'm still going to do some other questions, but do you want me to do another one that looks like this one? Are we good then? Okay, then a different kind of question is one that looks like this. This is question 15. And the function that we're going to deal with is g of v is equal to 5v take away 1 over v squared 2v take away 35. And we are explain, and it says explain using these theorems why the function is continuous at every point in its domain. And that's a pretty stupid question if you ask me. Oh, let me show you. Let me just show you the question. It's got all the answers here anyway. Sometimes they really do ask questions. I wonder to myself, why did they ask it? Because when you see the answer, you think that that's not really an answer. But here goes. Here is the guy they're talking about. If you click on that, it'll give you a list of the theorems, but most of them say that a function is continuous on its domain. So a polynomial is continuous on its domain, a rational function, a radical function. All of them are continuous on their domain, means they're continuous as long as you can find the value of the function at that point is going to be continuous, because that's the best way to phrase it. So in this question here, the correct answer was that one. G of e is a rational function, so it's continuous in every number in its domain. Isn't that in fact going to be the same sentence you're going to use every single time they give you one of these questions about using theorems? So it's kind of a nondescript. Now, this here is much more interesting. Find the domain. So that's the answer. Let's show you how you find the domain, because it's really 141 stuff. Here is a rational function. I want to know usable values of, in this case, v. First thing you should do with a rational function. Oops, I fixed it. Is factor it. Now I'm looking for two numbers that make negative 35. So that means one is positive and one is negative. And when I add those two numbers together, I get positive 2. So I'm going to go for plus 7 and negative 5. Right? So the first thing you should do when you want to find the domain of a rational function is to factor it. Now I can tell that there are going to be two values of v that are going to cause trouble. One of them is when v is negative 7, because that becomes 0. And the other one is when v is equal to positive 5, because that's when that is 0. Now, everywhere else, this fraction function is totally fine. So its domain is essentially everybody except those two numbers. And the way you use interval notation is you say negative infinity up to the first one, negative 7, curve bracket. Union, start another curve bracket, negative 7 to 5, curve bracket. Start a last one, 5 to infinity. Right, although that's a bit clunky, is it not essentially every number except for negative 7 and 5? And that's what that box at the end is. So if you get one of those questions that talks about when is a function, what's the domain of a function, or when is a function continuous? The domain of the function is going to be the same regions, the same values as when it's continuous. So this function is only continuous in these intervals. Are we okay with that? And then pretty much there's just a whole load of questions where you put them into Desmos, and then you ask questions about left continuous, right continuous, what's the value of a function at a point. So here's the last question I want to do from this section. And it says, suppose that f and g are continuous. which is nice. And you're told that g of 3 is equal to 5. And because it's continuous, it means that you can use limits and that they will exist. And that 3 times f of x plus f of x times g of x. So that entire thing has a limit of 48. And our job is to use that information to find the value of f, again at 3. Right, that's a weird puzzle, but it's actually solving. It's not as hard as you might think. If I take this expression and I replace essentially the x with 3, what I get is 3 lots of f of 3 plus f of 3 times g of 3 is 48. Now, since the overall limit exists, that means the value of the function exists, right? It's continuous. And I now have 3 times f of 3 plus, that's 5. So 5 times f of 3 is 48. That makes 8 times f of 3, 48. And so to find f of 3, divide both sides by 8. And there's your answer. So do you see, it wasn't really that hard. It was just trying to understand what they're telling you. If a function is continuous, won't its limit be the same as the value of the function? Which is all I'm doing here. And then once I wrote down this piece of information, I could convert what I knew into a number, and what I don't know, I can solve for. And we are finished that section, which means we are now going to be doing that section I skipped. And if you remember what I said is we are going to do the homework questions together. So this is 2.4. It's called the precise definition of a limit. Well, we've been finding limits and using limits for a week. So I guess the question is, how can we even, why are we allowed to do all the things that we've been doing? Yeah. So this is the formal definition of what it means for an overall limit to exist. So if I say to you, the limit, the overall limit as x tends to 3 of some function f of x is 5, right? Suppose I tell you that that's true. What does that mean mathematically? Well, we're going to look at this as if a lawyer became involved. And so imagine you were trying to argue what this would mean to someone. Well, you're saying that when you say the limit as x tends to 3 of a function is 5, you're saying as I choose values of x closer and closer to 3, the value of this function, right, its y coordinate, will get closer and closer to 5 to the point where you couldn't tell the difference, right? It's rounded off to the point where it is 5. Well, that's far too vague for a mathematician who wants to prove something. So what they did is they would go and say, okay, here is x equals 3. There you go. And here is 5. And put a little circle here. And here is some generic function called f of x. Now, do you notice that I've put a hole there? Isn't the overall limit of this 5? Right. but isn't the value of the function at 3 doesn't exist. And that's to stop people just saying, well, the limit as x tends to 3 of a function is just the value of the function at 3. Well, not necessarily. Isn't that thing got a limit and it's 5 and it doesn't even have a value at 3, right? The function doesn't exist. So then they say, okay, then, what do you mean by getting as close to 5 as an answer as you want, the closer you get to 3? So we would say, well, tell me a number. How close do I need to get to 5 before you're convinced that this limit is 5? And Brendan is pretty generous. And Brendan says, well, if you get to within 0.1 of 5, you've convinced me that's the answer. And Harman says, nah, it has to be 0.00000 away from it before I'm convinced it's 5, right? So we choose a guy called Epsilon. That's his name. And Epsilon is, how close do you want me to be before you're convinced that this limit is 5? And we're just going to call it 5 plus epsilon. And over here, 5 take away epsilon. So there's kind of a little band like that. So as long as I can show you that this function is going to home in 5 plus or minus epsilon. So it could be plus or minus, 10 to the minus 20, right? I'm making these big just because I want to see them, right? But typically, couldn't it be really close to 5, right? Almost on top of it. Then what happens then is that you would go down here and you'd go over here and you'd be able to find an x coordinate so that any number between here and here, right? So if I pick any value of x between whatever this ends up being and whatever this ends up being, won't the value of the function be within that range? And that is a very lawyer-esque way of describing what it means for the limit of a function as x tends to 3 to be 5. It says, you can get as close to 5 as you want. And once you've decided how close you want to be, I will find a range of values in x, close to 3 obviously, where every single number in that range will fall inside here. So can you imagine you could make that, I don't know, epsilon 10 to the minus a billion, theoretically. Even if you close that down to almost non-existent, wouldn't you be able to find a tiny little region next to 3 where that would exist? The precise definition of a limit is pretty much useless for practical purposes, which is why we don't spend a lot of time on it. And it's also extremely messy, for want of a better word. Now, we are going to be finding, in the questions that we're going to be doing, we're going to be finding the distance from 3 to the outside. And that fella is going to be called delta. So we're going to be given a function, a limit, and we are going to go hunting for what value should delta be to keep all of these guys in that range. Right, so I'm going to start with our first question then. So hopefully the one that I'm doing is going to be very similar to yours. And, pause a minute. I want to make it bigger. Okay, so there are going to be 6 questions. This is question 1. It's very visual. So give me a few moments just to close off the windows. There we go. I think the only good thing about it is it's also, at least for half of them, pretty quick. Right, I'm ready. Okay, here is what it looks like. Trying to explain some of the notation that's going on here. You see this guy over here, the absolute value of f of x take away 1 has to be less than 0.2. We're saying, look, there's the answer 1, plus or minus 0.2 takes you to there. That's there to there. So this little guy in here and here is essentially what they would call epsilon. Now, as this one drops down, you get 0.4, and this other side drops down is 0.1. The delta is the distance from here going that way, or the distance from here going that way. Now, do you notice on this side, the difference from the end to the middle, which is 1, is 0.1, and from here to here, it's 0.3. You always pick the biggest. So there's your answer. Right? From 1 to 1.1 is only 0.1 away. And the reason you choose the biggest is you want to guarantee, there I go again. The reason you want to pick the smallest is you want to be inside the thing. So 0.3 on one side, 0.1 on the other, choose the smallest. You don't need to put in the word smallest, by the way. Right, well, that's that one over with. Okay, here's the second one. Essentially the same picture. From here to here, it's what, 0.8, and from here to here, it's 0.4. Delta is 0.4. Are you at least happy the questions are easy to answer, even if the theory behind them is a bit messy? What that is saying is, if I want to be within 0.5 of the limit 2, I need to make sure that my x's are within 0.4 of 3. So can you imagine you went this side and 3.4 is about here. Wouldn't any value between here and here fit inside that window on the left? Right. Now this one is going to involve a little bit more work. I'm just getting the thing set up, and then we'll move to it. Okay, I'm ready to do that one. We're still looking for delta. Every question is going to be, what number does delta have to be, right? So that's the picture. If you go along here, you come down here, we're going to find that number. If you go along here, and then you're going to go down here, you're going to find that number. The distance from 4 to there is delta. The distance from 4 to there is delta. Whichever one of those is the smallest delta is the one that we are going to use. Okay, so the square root of x is equal to 1.6. Now I need to know what this question mark is. What do I need to do to both sides to find x? The square root of x is 1.6. What do I need to do to find x?
Should we square it?
Yeah, you should square it. And if you square both sides, you find x is 1.6 squared, just 2.56. So this guy here is 2.56. Now, if you go on the other side, the 2.41, well, if the square root of x is 2.4, that's basically the y coordinate is 2.4. Then if you square both sides, you'll be able to find out what x is. And 2.4 squared ends up being 5.76. So this guy here is 5.76. Right, now I need to figure out who delta is. From the center to there, if you subtract them, you get 1.76. And if you do 4 and there, you get 1.4. Is that 1 point? Yeah, you get 1.44. So on this side, the distance to the edge is 1.76. So that's a potential delta. And from the middle to this side, it's a 1.44. And so the answer to delta is the smaller of the two choices. And so in the box, in question 3, you would type in 1.44. Those 3 questions are the identical ones for everybody, so it's going to be the same answers each time. Okay, so that's going to be the answer to question 3. Question 4 looks like this. The function that we're going to be doing a limit on is y equals x squared. This guy is 1. So is this guy. So this is basically the limit as x tends to 1 is equal to 1. And we're going to have a guy up here called 1.5 and another guy here called 0.5. And the picture that they give you is a little guy coming along going down this way, a little guy coming along down this way. And they have little question marks just like the previous one. So I'm going to find out what the x values of these 2 points are. And then 1 to that distance is the potential x. Whichever of those 2 distances is the smallest will be my delta. So, top one, x squared is 1.5. Now, doesn't that make x the square root of 1.5? Right, because you take the square root of both sides. And we know it's positive because I can see it is. So the square root of 1.5 is approximately 1.225 because the question says, give me the answer to 3 decimal places. So I know that this guy here is 1.225. So the potential value of delta, which is the distance from here to here, is going to be 0.225. Now, if we go for the other side, if x squared is nothing 0.5, then the x coordinate for that is the square root of 0.5. And that becomes 0.707. So that guy there is 0.707. And the distance between the center and here is 0.293. And I look at that guy, and I look at that guy. This guy is the smallest. So your answer, the only thing you actually need to write down is 0.225. Now we've only 2 of these to do and we're done. You'll get 1 question like this in online test 2, but I won't give you a question on the midterm on these, and I won't give you a question in the final on these. Any questions before we do the last 2, apart from what the heck are we doing? We're essentially trying to find how close to 1 do you need to be to get an answer in this range. That's essentially what delta is. How close to 1 do you need to be to get your answer in this range? Are we good? Cool. 2 to go. Question 5. It says a graphing calculator is recommended. Definitely is. But let's write down what the question tells us. I'm just copying it down. If the absolute value of x take away 2 is less than delta, then the absolute value of the square root of x plus 5 take away 3 is less than 0.4. And we're being asked to find out what delta has to be to 3 decimal places. So I have to be able to look at this and identify all the key features. So here's the first thing. I need to know what y is equal to. That's him. So my function is the square root of x squared plus 5. So I'm going to go to our calculator and figure out what that guy looks like. So y equals clear. Put in the square root of x squared plus 5. That's fine. Now, what do you think that 2 is telling me? On my diagram, what is that 2 telling me? And I guess indirectly, what is that 3 telling me? What does that 2 have to do with down here? And what does that 3 have to do with over here? Okay, this is saying that the distance between x and the number 2 has to be less than delta. Delta is here, right? It's in the x-axis. So that means 2 here. So that's the x coordinate of the point that we're interested in. Now this fella here is 3. That's that guy. Okay. So I'm going to go to my calculator now. Going to do a window. I know I need to be pretty close to 2. So I'm going to do from 0 to 3. That seems reasonable. And then I'm just going to do a zoom 0 and see what it looks like. Maybe choose a different y value here. There we go. So it kind of basically looks like that. I'm exaggerating a little bit, but that's what the shape looks like. And right, that's how much. Now, the next piece of information I'm going to use is this fella here, which says the y value of the function, take away 3, has to be 0.4, which is another way of saying 0.4 away from 3. So on this side here, that's going to be 3.4. On this side here, I wish my curve was lower, but 2.6. So plus 0.4, take away 0.4. So you go along, you get an answer down here. You go along, and you get an answer down here. Okay, that's us at the point where all the other questions were, right? I've got a graph. I've got 2 missing x coordinates. Once I find out what these are, won't the shortest distance from 2 be my delta? Okay. The function is the square root of x squared plus 5. And I want to know when is it equal to 2.6. And then on the other side, the square root of x squared plus 5, I want to know when it's 3.4. And just to remind you where these two come from, 3 plus that, 3 take away that. Okay, if you forget where this came from and just focus on solving this equation, as long as you do it to both sides, it's okay, right? So let's do this one. What should I do to both sides to get closer to solving for x? It's normal algebra now. Don't worry about where it came from. What do you do to both sides to get closer
Square
to
them.
solving? Okay then. So if you square both sides, you get rid of the square root. And let's find out what 2.6 squared looks like. And it looks like 6.76. Now the next line would be subtract 5 from both sides. Great. And what would the last thing need to be? I know what x squared is, but what do I do to both sides to find what x is equal to?
Take the square root again.
Okay, so take the square root of both sides, and now we should be kind of finished on that side. And I make that 1.327 to 3 decimal places. So this guy here is 1.327. And the distance from 2 to this point is nothing 0.673. So that might be my delta. We'll find out in a minute if it is. If you square both sides again, you get x squared plus 5 is 3.4 squared. You get x squared plus 5 equals 3.4 squared, which is 11.56. If you then take away 5 from both sides, you get 6.56. Take the square root of both sides, and you are done. So the square root of 6.56 is 2.561. If this guy is 2.561, the difference between the middle and this guy is 0.561. And after all that work, the only thing you write down is that delta is 0.561, the smaller of the two. So as long as you're within 0.561 of 2, your answer will be between these two extremes. I'm not sure if I can say are we good, but are you at least following the general direction of what's going on here? That we've got the same puzzle every time. How close to 2 do you need to be to get your answer in this range? They're just making it more and more difficult to figure out what this range is, right? By using this notation up here. But once you know the code, you can figure it out. That's the x coordinate, that's the y coordinate, and that's how close to 3 you need to be. That's what that's telling me. So last one. Question 6. It says, if x take away pi over 6 is less than delta, then cosine squared x take away 3/4 is going to be less than, and this is the only question where things vary. In my question, it's 0.15. When you do your homework, that could be 0.2 or 0.6 or who knows. But that guy is my answer. So you will not be able to use my delta unless you get really lucky and that number's the same. So you're going to have to adjust it a little bit based on that. Now, everything I need to know is here. This guy here right? See this pi upon 6? That tells me the number that goes there, right? That's pi upon 6. That cos squared there is telling me what f of x is. That 3/4 is telling me that that guy is there. And now I'm going to turn that into 0.75 because you can't really mix and match fractions and decimals. So that's telling me that this is 0.75. That guy there is telling me to be 0.15 either side of that. So can you imagine that this guy here is going to be add 1.5, so that's 0.9. And if you take it away on the other side, it's 0.6. So we're going to have a guy that goes like this. We're going to have a guy that goes like this. We're going to have another guy going like that. So I'm going to plug in to my calculator y equals bracket cosine x, close the brackets and squared. Everything should be in radians. Double check. It is. Okay, that's good. I'm going to go to my window. I know I want to be close to pi upon 6, which is about a half. So if I do 0.4 and 0.6, that's a rough guide to what the thing looks like. I'm going to do zoom to fit. Okay, so the function is pretty boring. It basically just travels down the way, right? So I want to know that guy, and I want to know that guy. Now, once I find out what these guys are, I'll find out how far away they are from pi upon 6. And whichever one of these two is the smallest is our delta, right? Now, being the last question, things are going to get kind of messy, even more so than the others. For instance, the function that I've got is cos squared x. And I want to know what value of x is it 0.9, because that's going to tell me this number. So we have to solve this trig equation. And it's going to be to 3 decimal places. So it's basically, I'm going to let the calculator do most of the work. So, would you agree that you take the square root of both sides to find out what cosine x is? And typically there's a plus or minus, but can't we make the assumption based on my picture that it's obviously a positive one, right? There's no reason it would be negative. Now, what do you do to find x? If you know the cosine of x, what do you do on your calculator to find x? Think 142.
Inverse cosine.
So we're going to do the inverse cosine. And I haven't even bothered to figure out what that is as a decimal, because isn't it just going to be ugly, and I might as well let the calculator do it all at once. Right. So the first missing x is the inverse cosine of a square root of 0.9. And the answer that I got is, to 3 decimal places, 0.322. So that guy there is 0.322. Then we work on, oh, I should be careful. This guy is 0.322. Right, it's this. Now, the other one is going to be that guy, right, the 0.61. So cos squared x is going to be equal to 0.6, and I want to find out what value of x makes that happen. So if you take the square root of both sides, and if you then take the inverse cosine of both sides, there we go, inverse cosine of the square root of 0.6, we get the answer 0.685. So this one here is 0.685. I want to know how far away that is from this middle, how far away that value of x is from the middle. So let's see. If you're doing this one, pi upon 6, take away 0.322. I need a decimal here, so there's pi divided by 6, subtracting this number. And the answer I get is nothing 0.20, I guess it's 2. Now if I go the other way, right, this one, I'm going to find out 0.6. But I can't read them on right. 685, take away pi upon 6. That's going to tell me this distance. So 0.685, take away pi upon 6. And this is 0.161. Right, these are the two potential deltas. Isn't that the smaller of the two? In my question, that's what's going to go there. Now, since this is the only one of the whole 6 that varies, suppose that wasn't 0.15. Suppose your question, it was 0.12, right? Wouldn't this guy become 0.75, add that guy? Right, so if you imagine what that would look like, 0.75, add that, so that would be what, 0.87, and then that guy, take away him, and you would get 0.63. You see, these would be the two numbers that you would be solving your equations for, right? So if you change the y values, obviously cosine squared x is going to be equal to your particular y values. And once you've got your two numbers, you'll do pi upon 6, take away the little guy, and the big guy, take away pi upon 6 to get your potential deltas. And then the last decision is whichever is smaller, there's your answer. And I'm good. I'll tell you how good I am. It's exactly 850.